Hi, this is Jeff Spencer, Math 120 instructor for the Community College of Denver, and this is our video lecture over Section 8.6, which covers cars and car loans. There's a lot of information in this section. We're just going to cover some of the stuff at the beginning about looking at the payment of a loan. The big thing that we're really focusing here on now is from the last section we were looking at savings plans, and now we're looking at paying off loans. And two really popular kinds of loans are car loans and home loans, which are called mortgages, which we'll look at in 8.7. So we're going to compute the monthly payment and interest costs for a car loan. That's the main thing that we'll be doing. And that really after that, we'll just look at the pros and cons of leasing versus buying. That's really just kind of where we'll stop. So the mathematics of financing a car. So a loan that you pay off with weekly or monthly payments, nearly all of these car loans and home loans are monthly payments, or payments in some other time period, is called an installment loan. The advantage of an installment loan is that the consumer gets to use the product immediately. So you get to have the car immediately and drive, or you get to move into the house immediately. The disadvantage is the interest can add a substantial amount to the cost of the purchase. So let's begin with car loans, which you make regularly monthly payments called fixed installment loans, which means that the monthly payment is the same for every month until you pay it off at the end. So fixed just means same, fixed equal payment. So the formula that we're going to look at to figure out the monthly payment based on how much you borrow, which is P, and the interest rate and the number of compoundings, which is usually monthly, is this formula here. So just to show you on my formula sheet like we've shown before, this is formula number 10. If you look, they're very similar, basically exactly the same. Nothing different on this one as opposed to 8 and 9, which were slightly altered. So we're going to use this formula. The big thing I am going to do is I'm just going to insert a parenthesis for this exponent there. So let's go back to the lecture slide. Okay, so suppose that you decide to borrow $20,000 for a new car. You can select one of the following loans, each requiring regularly monthly payments. That's nearly always the case with car loans or mortgage loans. We have regularly monthly payments. So you can do a 3-year loan at 7% or a 5-year loan at 9%. So generally the shorter term loan will have a lower interest rate and the longer term loan will have a higher interest rate. That's not always true, but generally speaking. So it says find the monthly payments and total interest for loan A, same for loan B, and then compare them. So the monthly payment for and total interest for loan A, let me show you this in the calculator. So we're borrowing $20,000. The interest rate is 7%. We're doing monthly payments. So we're going to plug this all in. They rounded to the nearest cent or to the nearest dollar. I'm going to round to the nearest cent. So to show this, I'm going to show 20,000 times 0.07, which is the interest rate, divided by 12 monthly payments. So I have my parenthesis there. Then I'm going to divide. Now I have a bracket here, so I'm just going to use a parenthesis. 1 minus another parenthesis here. 1 plus 0.07 divided by 12. And the parenthesis there. To the, and then the negative key, remember, look out for your negative key. It's not the minus key, it's a negative key. It's down by your decimal. But I have to do a parenthesis for the exponent. Negative 12 times 3. So this is 3 years monthly payments. And then I end the parenthesis for the bracket down there and get a payment of $617. Oops, $617.54. They rounded that to 618. Okay, so that's how you type all this formula in one line. Then the second part that they're doing in this slide is to figure out the interest. Now remember, the interest is we're making this payment every month for 3 years. So 618, they didn't show the times 12 times 3, but 12 times 3 is 36. So 618 times 12 times 3 gives us, they're not even showing the work here, so let me show you. Okay, so 618 times 12 monthly payments for 3 years, you'll have paid $22,248. Okay, so that means to borrow the $20,000, you'll have paid $22,248. Why are you paying more? Because of interest. You don't get to borrow money without interest. So the difference between that and the $20,000 that you borrowed is the total interest, $2,248. This is part B, determine the monthly payment and total interest for loan B. They type this in and get a payment of $415. Remember, this is over a period of 5 years with a higher interest rate. So you'll see that actually compared to the previous one, the payment is lower. The monthly payment is lower, which appeals to a lot of people. Ooh, lower monthly payment of $415. But if you look at the interest, $415 times 12 times 5, which is 415. Let me go to the wrong slide here. Oops. 415 times 12 times 5, monthly payments for 5 years. You'll spend $24,900 to borrow $20,000. So your interest will be $4,900. So the interest is more. So here's a comparison. The monthly payment at the 3-year loan is higher, but the total interest is lower. It's because you pay over a less period of time with a lower interest rate that the interest is lower. The 5-year loan has a lower monthly payment, but has higher interest. And that is a classic thing when you loan money. Higher interest rate, higher interest, and shorter term, lower interest. So if you can afford this monthly payment, excuse me, of $618 versus $415, you should do it because in the long run you'll save money. It looks like you'll save over the course of this about $2,652. So keep that in mind. There's also an opportunity with leasing when you get a car. Leasing is a practice of paying a specified amount of money over a specified time for the use of a product. Leasing is essentially a long-term rental agreement. A closed-end, so it's a rental, it means you have to return the car at the end. A closed-end lease date, each month you make a fixed payment based on estimated usage. When the lease ends, you return the car and pay for the mileage in excess of your estimate. An open-end lease is each month you make the fixed payment based on the car's residual value. This is a little bit more complicated, but either way, you're basically renting the car to have it for a period of time, but you do have to return it. So the advantages of a lease is that they require a very small down payment or no down payment at all. Lease payments for a new car are lower than loan payments, but the problem is you don't own the car. So most people can lease a more expensive car than they would be able to buy. You might have seen this on I saw this on the show Ballers, where the agent was telling the rich football player to lease a car because it's cheaper up front and the car loses a lot of value. And so if you want a really fancy car, very expensive car, you should just lease it for a short period of time to show off to all your friends. But the problem is when the lease ends, you return the car to the dealer and not have to be concerned about selling the car. That's a nice thing. You don't have to worry about selling the car, but it's also you don't own the car. So that's the big disadvantage. The other big thing with lease agreements is they have mileage limits. So if you go over the extended miles, you could incur some penalties. So sometimes with these penalties, the total cost of leasing is more expensive than financing a car. And when you're financing the car, even if you don't pay off the loan, you could always sell the car and maybe pay off your loan that way. So leasing the car, you got to keep it in great condition, which could be stressful. Leasing does not cover maintenance, and there are penalties for ending the lease early. So leasing is a thing kind of for rich people if they want really fancy things. I wouldn't recommend it. And I wouldn't actually recommend financing a new car. I would recommend buying a used car. But that's really up to you. So the main thing that you're mathematically going to be asked is stuff like this first example, to figure out a monthly payment and total interest. We'll see you next time.